Hello. You should hear me now. You should be able to see the desktop. Okay. Does everything seem okay? Can you hear my voice? Do you see the desktop? Everything seem normal?
Yes.
Okay.
Yep.
Great. Thanks. Okay. 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 So we're going to continue talking about classes today. There's another programming assignment up there now. This is the last programming assignment. It's based on what we're going to do today. So let me download it now, but I'm going to download it and unzip it, but not look at it quite yet. We'll look at it before the end of class, because after we've talked a little bit today, I can explain better what's in this homework assignment. Okay, so the homework assignment is really very much an extension of what we're going to do today. Okay, so we're going to pick up where we left off on Tuesday when we were doing this example of a point class. So we're going to redo this example, and we're just going to keep working on this example to see how we design a class. How do we go about and designing a class on our own? Okay. Right. So what I'm going to do is I'm going to open a new tab for Java Visualizer and start from scratch. Okay. Now, the idea is that what we're talking about are these sections on anatomy of a Java class and designing classes. So we're talking about what's in here. We're also, and there's another reading assignment for next week. This is probably the last reading assignment, more on writing classes. And so, like, what we're talking about is all of this at once. It's a big blob of ideas, and it's a little bit hard to separate them sequentially. So we're kind of actually, we're going to be talking about them more or less all at once. So it's these two sections and these three sections. How do we design a class so that someone else we can use it to solve a programming problem? Hey, now remember, classes are something that hold data. Like a string class holds the characters in a string. An array object holds the entries in the array. Scanner objects held what somebody typed at the keyboard. What they typed at the keyboard it was held in a scanner object so that we could do something like ask for the next int or next double. So we want to design a class that holds data and then lets us call methods on that data. So the example we're going to do is going to be, we're going to design a point class. Okay. So what we're going to do is we're going to assign a class that describes points. So we're going to describe a point class, and a point and it's going to be a point in the plane. Okay. So the data is going to be an int x for an x coordinate and an int y for a y coordinate. And that's the data. Okay. So that's our, oops, I got the brackets in the wrong place. Okay. And up here, I'm going to define a use point class. Now, up here, notice I got two classes now. This is the class that's going to hold the main method. So it holds the main method where I can write my code to use instances or objects of this class, which I'm going to define down here. You can only have one public class, and that's the class that has the main method. So this class, if I put the word public in front of it, it wouldn't compile. So I'm not supposed to put the word public in front of that. It's kind of what people sometimes call a private class. So this class can make use of this class, and this class, since it's public, it can hold the main method. Like I can't put the main method in here because this is not a public class. Okay, so this is the class that's going to use instances of this class. So for example, I can go down here and say point P equals new point. So right away, I can create an object of this class. Okay. Now it should work. No, but notice it doesn't work. Notice how I got it. My program crashed, and this is a bizarre. We mentioned this the other day. This is a bizarre thing about the Java visualizer. It has a point class buried somewhere inside of itself, and our point class is competing is conflicting with their point class. And I remember when I first noticed this, it took me a long time to figure out what was going wrong. What was causing this weird error message down here. And I finally figured out it's that they have a point class that they shouldn't have, and it conflicts with a point class that we're trying to define. So what I'm going to do is I'm going to change the spelling to this. Kind of stupid, but I'm going to change it to POINTT just to see. Now I'll be able to do, okay, there's my P pointing at a point object. I've created my own point object. And what we want to do is elaborate on this and see more and more about what we can do with it, with this code. Now, what would people use a point for? The Java language has its own point class. I mean, the Java visualizer built one into it for some bizarre reason. I don't know what they use it for, but the Java language actually has a point class, and it's used for graphics programming. They use a point to describe a location on your computer screen. The X and Y coordinates are X and Y coordinates on a computer screen. There was some people sometimes refer to as pixel coordinates. Okay, so the Java library has a point class that's used to describe points in a plane, and that's why it's integer coordinates, because it represents not points in a plane like in a geometry class or a math class. It represents points on a computer screen, which are integer coordinates, because the computer screen is made up of dots. A computer screen is made up of lots of little dots, and these would be the coordinates of one dot of the computer screen. A dot in the computer screen is called a pixel, which means picture element, an element of your screen. Okay, so they have integer coordinates, unlike in a geometry class or a calculus class or an algebra class where you would use doubles for points. Here, we'll go ahead and stick with ints because that's what Java language does. And the idea is it represents points on a computer screen, integer coordinate points, pixel coordinate points on a computer screen. Okay, so that's what it would be used for. That's what it might get used for. And when we get to the homework assignment, you'll see a little bit more of how you might use a point class. In the homework assignment, there's a point class, and we'll see a little bit about how it gets used. Notice that there's a circle class and a rectangle class. And you can kind of guess how circles and rectangles might use points. A point is the center of a circle. So this would represent a circle, and the point could represent the center of it. The corners of a rectangle are points. So that'll be a connection between points and circles and rectangles. Okay. All right. So now let's go here and start saying what we could do to make this more elaborate. Okay. This guy here is called a constructor. It constructs an object, a point object. Its job is to construct. Remember, we said a line like this does three things. This constructs the object, this creates the reference variable, and this puts the arrow between the reference variable and the object. On the other hand, if I do something like this line didn't do three things, this line only did two things. It created another reference variable and copied the arrow from here to there. So that created an alias. So this line here creates an object. This line here only creates an alias. Remember, this what it looks like is there's the object, and okay. There's the, I'm sorry, let me step through. there's the object, there's the reference variable pointing at the object. So that this line created the object, it created the reference variable and made the arrow point, the reference variable point to the object. The next line just creates another reference variable with another arrow pointing at the same object. We call that an alias. Okay, so the constructor is the thing that actually creates the object. And you have to put the word new in front of the constructor. It's a little bit redundant. Like in C++, in C++, you don't have to write the word new. You can just write this because that's the constructor that builds the object. Saying new point is actually kind of redundant because this thing creates the new point. Okay, so but Java, for some reason, makes you write the redundant word new. C++ actually doesn't make you write the redundant word new there. Okay, all right. So create these two together. Create, and you always can use a constructor with the word new, and every time you use the word new, you have to call a constructor. So they always come together. So in a sense, they're a bit redundant, but you have to write it this way. That creates the object. That creates the reference variable. That makes the reference variable refer to the object. Here, that creates the reference variable, and that makes the reference variable a copy of that reference variable. Okay, so we're not creating another object. So we have two reference variables with only one object. Okay, now, what if I want to put numbers into the point? What if I want the point to be what if I want the point 2, 3? Okay, well, right now I can't do that. Now I want a point that would be representing the location. X coordinate is 2, Y coordinate is 3. So what down here I have to define another constructor. So what I'm going to do down here is I'm going to define it's a lot like defining a method. I write public point, and this constructor is going to take in an X and a Y parameter. Those are going to be, so here this thing has arguments 2 and 3. This has, just like a method, parameters X and Y. And when I call that constructor, that argument goes into that parameter, and that argument will go into that parameter. But now I want that parameter to go into that. Now these are called fields. I want that parameter to be stored in that field of the object. Okay, now these things are called fields, but they're also called, you can also call them instance variables, or you can call them attributes. And unfortunately, everybody and his brother's got a different name for these things. Actually, there's pretty much 3 names for this thing here. This is the data that's in the point. This is a field of the point, or an instance variable of the point, or an attribute of the point. Okay, so that's a field. So that's a field, and this is another field. So we have 2 fields in this. Okay, so this object has 2 fields to it, or 2 attributes, or 2 instance variables. It's got an X field that we think of as representing the horizontal component of a point, and it's got a Y field that we think of as representing the vertical component of the point. Okay, I call the constructor with 2 arguments. That argument, just like a method call, goes into that parameter, and that argument goes into that parameter. Now I want the value in this parameter to get put into here, but I've got kind of a problem. If I write X equals X, that doesn't make sense. What I mean is, I want this X to be that, and I want this X to be that. I want to copy from here to here. Now, Java's got a name for this X. It is this X. Okay, that's how I say this X over here. This is meaning the object that I'm building. The class is a template for creating instances of itself. And every time you call the constructor, you're creating a new object with its own X and its own Y. So if I call this constructor, let me just do up here a couple times. Let me give that a new name. Point P2. I'm going to create a bunch of points. Here's a point 3. Here's a point 4. I'll give this one coordinates, say 4, 5. And I'll give this one coordinates, say 6, 7. Now, notice that I'm repeatedly calling this constructor. Okay. First, I call the constructor with these arguments. So the arguments are now 4 and 5. Arguments are now 6 and 7. So like when I make this call, 4 gets copied into here, 5 gets copied into here. I want the 4 here to go over here. Now that's not going to override the 2 because the 2 is in a different object. This is the tricky part. When the visualizer will show us pictures of this, but when we look at it on the page, we have to, in our mind, think real hard about what's going on here. You call this constructor. The argument is 2. The argument goes into the parameter. We want to copy that parameter value into that field. So we end up with a 2 in here. Then later on, we call this method, this constructor again. Now the argument is 4. So the parameter is 4. We copy 4 over to here. It does not clobber the 2 because the 2 is in a different object. This was building an object. This object holds the 2. This is building another object. The object holds the 4. This here is a pointer to the object that's being built. So when I did this call, this was pointing at the object that's holding the 2. When I do this call, this is holding the object that points at that's going to hold the 4. Okay? Same thing with the Y. This dot Y equals Y. Now what that's saying is copy that Y over to this. Oh, if I left it like this, Java won't complain. And what Java will do is it'll copy this value on top of itself. This is saying read that Y and take its value and store it back in that Y. So it just copies a variable to itself. It'll compile. The Java language says that makes sense. It's kind of a dumb thing to do, but that makes sense. It copies Y back to itself. But I want to copy that Y from there over to here to store it in the object. So I have to say this Y. Okay?
So, Professor?
Yeah.
So it just stores the whatever that variable is in the class then?
Well, no, in the object. The class is used to describe how the object is built. The common analogy is the difference between a cookie cutter and a cookie. You know, you have a cookie cutter in the shape of a star, and you have a bunch of dough on a board, and you use the cookie cutter to cut out dough-shaped stars. Okay, the cookie cutter is not a cookie. The cookie cutter is used to make the cookie. The class is the cookie cutter, and then it's used to stamp out cookies, which are objects in computer memory. See, watch, you kind of see it in the picture when we get over here. What would I forget? Oh, I need to give this parameters now. Since I changed this thing to have parameters, I need to give this one parameters. I'll just give it 0, 0. Oops. Okay. Now, what I'm doing here is I'm saying use this class to stamp out over here. Think of this as the dough. You're going to stamp a point-shaped cookie in the dough. See, there it is. There's the point-shaped cookie. Okay. Now I'm going to stamp another point-shaped cookie in the dough, but this one's going to hold different data. See, now I stamped one cookie in the dough, another cookie in the dough. See, they're separate cookies, They're separate objects. The class is the thing that's used to say what an object looks like. So think of the class as the pattern, as the shape. And a lot of people use the word shape. We talk about the shape of an object. The shape of this object is it holds 2 ints. A lot of programmers refer to the shape of their objects. They'll say, oh, the shape of the object is 2 ints and a double, or the shape of the object is two strings and an int. Okay, the class describes its shape, and when you call the constructor stamps a. This is like a raw. Notice that there's 0, 0 in the object right now because we haven't yet got to these 2 lines of code here. When we get to, so we've called the constructor. We're at line 22. The first thing the constructor does is stamp out a raw cookie and doesn't do anything with it. Like it doesn't put the numbers in it yet. So it's kind of like stamped out an object. It's used the shape to stamp out the object, but it hasn't put the actual values in there. See, it's about to put this 4 into there, and it's about to put this 5 into there. Now, remember, the 4 came from that argument, was passed to that parameter, and now we want that parameter to be copied to this field. Okay, so we went from argument. No, actually, let's see. Oh, well, you don't see the argument in this picture. So the argument was up here. That argument copied into that parameter. There's the parameter. So there's the argument that's been copied into the parameter. Okay, so that argument got copied into that parameter. That's line 22 of the code. See, we're at line 22. That actually, you'd think it would be line 21 where they showed that. Yeah, you would think this would show line 21 because line 21 is when the argument gets put into the parameter. But actually, it's line 22 because it's also what's happened is the argument got put in the parameter and then a blank object got stamped out. So that's why they think of it as if we're at line 22. Line 22 to them represents the stamping of the blank object. And then line 23 is going to put the 4. The argument gets put finally now into the parameter gets put into the object in memory. And then we put the Y parameter into the object. Okay, now we're done. We're going to return. Now, see the word. Oh, see how the word "this" is in here? That's this guy. This points to the object we're building. This one was built a while ago. This one was built a while ago. We're currently building this object. Okay, we're building this guy. Okay, and Java uses the word "this" to represent the thing that we're currently building, the object that we're currently stamping out using the template that is the class file. You have to kind of force yourself to think in this way. The class is the template. The objects are the things you make out of the template. Another word would be mold. The class is the mold, and you use a mold to make an object. The mold is in the shape of the object, but it isn't the object. A mold that you use to make a vase, molds that are used to make metal objects, like when you pour metal into a mold and the metal cools in the mold. The mold has the shape of the object, but it's not the object. The class is the cookie cutter. It's the mold. The object is the thing that you make using the cookie cutter or the mold. Okay. So right now, and the word "this" is pointing at the thing that's currently in the mold. This is what's being made in the mold right now. We're making that object. So in our code, this refers to the object we're currently making. This refers to the object we're currently making. Copy the argument, the parameter, into the object we're making. So that copies it from here into the object. See, it copied from Notice that, see this line of code here says copy from that variable to that variable. From a variable that's a local variable in the frame, copy from the local variable in the frame to the instance variable in the object. So that X is an instance variable. That X is a local variable or an argument. You know, we have lots of names for these things. You know, this guy is an argument variable, a parameter. It's also called a local variable. So it's a parameter or a local variable. It lives over here in the picture. This guy is an instance variable. It lives over here in the picture. In my code, to distinguish between this one and this one, I use the word this. See, this is a reference, an arrow points down to there, and then there's the X. So this, follow the arrow, get to X. So this, think of the dot as the arrow. This, follow the arrow, you get to the variable. That's where I want to copy this variable's value into that variable. Okay? So now I can stamp out as many objects as I want in memory. Stamp, stamp, stamp. They all have the same shape. They all have the shape of two integers, but they have different values in them. 0, 0, 2, 3, 4, 5, and then I can make another one. Okay, now I got 4. I stamped out 4 different objects in memory. Okay, all right. So we've got constructors that build the object. We've got instance variables that describe the shape of the object. Okay. Now, before I had zeros, I had nothing in there. Okay. This creates a default object. What that means is that it puts in the variables values that are default values, not the values that I choose, but the values Java chooses. Now, when I defined this earlier, if I delete this, I get a default constructor for free. When I put this in there, I lose my free default constructor. This is a weird rule of Java. If you don't define any constructor, you get a default one for free. If you define a constructor, which you almost always do, you lose the free default constructor, so you got to put it back in there yourself. So I have to now say public point, no arguments. This is the default constructor. And I can even just leave it empty because it's just going to give me the default values for X and Y. If I wanted to, I could make the default value. No, the default values are 0. But if I wanted to, I could do something like this. This dot X equal 42. And this dot Y equals negative 42. If I wanted to, I could give my object really weird default values. Sometimes you do want the default values to be different than the ones Java chooses, but I can go ahead and just let Java pick the default values by just putting nothing in there. Okay. Notice the rule is if you define a non-default constructor, you lose the default constructor that you got for free. If you don't define any constructor, you get this default constructor for free. Okay, so I didn't have, if I delete this one, I can delete this one. But if I delete this one, then I can't put numbers when I create the object. So this is the way I want it to be. I want there to be a default constructor. This is the way you usually want things to be. A default constructor that puts default values in your object, and then constructor that lets you choose the values. Okay. Right. So now let's just go back and watch this again. Constructors are like methods. So you call them. So this line of code is going to jump down here to line 21. See, I jumped down to, line 22. And notice that built an object with the default values in it. Okay. And then I'm ready to return. I'm done building the default object. So I'm going to return a pointer to that default object. Okay, so now P refers to that default object. Okay, then I create an alias to it. Okay, now I'm going to jump down to this other constructor. So I'm going to jump down to line 26. Okay, so this now is going to call line 26. Okay, notice it starts off by building a default object. See that the first line of the constructor always builds the default, and the default, not my default, but Java's default, which means that the integers hold zeros, Booleans hold false, doubles hold 0.0. So the first thing the constructor does is build a default object where all the fields hold the Java determined default. If you want, then you can update that. Okay, so now I'm going to go in and start modifying the default values with my arguments to my constructor. Okay, so I modify my default values. Okay, now I finish. Now see, I'm down here at the end. I'm about to return. Okay, I've built this object. This keyword is pointing at it, and what I'm going to return is this arrow. See, I'm going to return to line 8. See, I came from line. You can't quite see it anymore. I came from line 8. I came from line 8. I jumped into the constructor. Okay. Now I'm at line 29 in the constructor. You know, I can't get all that code at once, but I'm on line 29, and I'm about to go back to where I called the constructor. Because what I need to do is this arrow pointing at this new object needs to get put into P2. Whoops. The idea is the constructor, I'm really doing this right-hand side right now. I'm doing this part here. We're in the call to the constructor. The constructor is building this object and it's holding an arrow to the object it's building. It's going to return that arrow to P2. Okay, all right. So now watch what happens. The Java visualizer does this kind of weirdly. I'm about to return to line 8. Now, when I returned, my object that I'm building disappears. It doesn't really disappear. That's a quirk of the visualizer. What happens is that this arrow is going to disappear and it's supposed to get replaced by an arrow from P2. But P2 hasn't been made yet. So what happens is the Java visualizer loses this arrow disappears and another arrow is supposed to replace it, but temporarily there's no arrow. So the Java visualizer stops drawing the object. It doesn't want to draw an object that doesn't have an arrow to it. What's really going on is the object's sitting right there. It just doesn't have an arrow pointing at it right now. The object is sitting right there. We're back to line 8. We finished the right-hand side, which built that object. We're about to do this left-hand side, which creates P2. Then we can put the arrow in, and the object reappears. From the point of view of the visualizer, that object disappeared and reappeared. It didn't get destroyed and recreated. In real Java memory, that object just sat there the whole time. But the visualizer has a little quirk to it that when in that intermediate step, when this arrow disappears and is about to be replaced by another arrow, while there's no arrow there, the object seems to disappear from memory. Then the arrow, then we finish that line, we create the P2, put the arrow that was in P2, and now we have this object. So now we're on line 9. We're about to do this all over again, but we're going to construct another object with different parameters. So we jump back down to line 26. See, we called that constructor. So we're down here to line 20. We're going to be down here at line 26. So we're at line 26. That builds the default object temporarily. So we start with a default object, copy our parameters into the default object. So we're going to copy 4 and 5 into here and here. Okay, so we've copied the parameters into we copied the parameter variables into the instance variables. okay? And we're about to return that arrow to, well, we'll return it back to line 9. So remember, we came from line 9. Line 9 would return the arrow to P3. Now, P3 doesn't exist yet. See, P3, we're on the right-hand side here. So P3 hasn't been created yet. So we're on the right-hand side. So when the arrow gets returned to P3, first P3 has to be made. So the arrow disappears and the object disappears. See, the arrow disappears and the object disappears, and then it reappears when the arrow gets copied into P3. So yeah, it's when P3 gets created that the visualizer can put the arrow in it, and then the visualizer redraws the object, but the object did not disappear from memory. It was there all along. Yeah, there's little rough edges to the visualizer. It's a great tool, but it's still in development, so there's still some rough edges to it. And this is an example of a little rough edge. I mean, one rough edge was it makes us, we have to spell this thing P-O-I-N-T-T. That's a rough edge in the visualizer. There's a bug in the visualizer that their internal point class is somehow conflicting with ours. Another little quirk is how these objects disappear. After the constructor returns, but before you assign the arrow the constructor is returning to the variable, the visualizer shows the object is temporarily disappearing, but it doesn't really. Okay? Okay. Now let me do another thing. Let me define another constructor. Right now I have a constructor that takes no arguments and gives me default values. And I have a constructor that takes 2 arguments and fills in the thing. Now let me do something that's kind of quirky. It's really not a good idea to do this, but just I want to show an idea. Public point. I'm going to define a partial constructor. Since I don't specify an X in my constructor, I'm going to be, this is going to be a constructor that only sets the X coordinate in the new point and leaves the Y coordinate as its default value. Sometimes you do this. It's actually not that uncommon to have, in the case of a point, this is kind of weirdly thing to do. Why would you only specify, that puts a point on the X-axis. Essentially what it does is, since the default value for Y is 0, this puts a point on the X-axis. Okay, so you might think that's kind of convenient. Okay, then up here, I can go up here and create a point P5 equals new point 8. Okay, so there's a point. Now, I only have one argument now. The argument is 8. That's the only argument now. There's only one argument. Let me go ahead and visualize this. You'll see. Let me step through the first few objects. Okay. Oh, one more. Okay. Okay. Now I'm ready to create this guy here. So I'm at line 11. So I've finally got to a line 11. See, the yellow line is 11. So I'm calling the constructor now with one argument. Now that means I'm jumping down here to line 32, which really means I'm jumping to line 33. That's the line that starts off with the blank object. So see, there I am at line 33. I've got the blank object. So X has got a default value and Y has got a default value. Now I put my value into the X, and Y still is default value. Okay, so I got a point on the X-axis. That's all right. Kind of quirky, but it seems like it might be a good idea. But now watch this. Suppose I want to put a point on the Y-axis. So here's my okay. Turns out this doesn't work. Point int is already defined in class point. This guy is redundant with this guy. And here's what's wrong. Look up here. Which one am I doing here? How can Java tell if 8 is meant to be X or 8 is meant to be Y? Java can't even begin to guess which one you meant. See, what you're saying is point with one integer. Here you say, well, that integer is called X. Here you say that integer is called Y. But Java, see up here, there's no name. It's just saying one int. And it can't tell if you mean, do you mean the X or do you mean the Y? It can't tell. So it doesn't let you do this. Okay. So this one conflicts. This one's not allowed. This conflicts with, I'll put it, it conflicts with that. Public point int Y to Java essentially looks exactly like public point int X. It doesn't, the name of the variable doesn't mean anything to it. It's saying that this is a constructor that takes in one int. This is a constructor that takes in one int. Here's a constructor call with one int. It doesn't know which one I mean. See, that's a constructor call with one int. It cannot tell if it's this one or this one. So you can only have one of these. These are called, notice that I've got 1, 2, 3, 4 methods all called point. That's called overloaded constructors. But this one has no arguments, this one has 2 arguments, and this one has 1 argument. So Java can tell these apart. Like here's another thing that would be not allowed. Suppose you just wanted something like this. Or you're reversing the roles of Y and X. Okay, so the first parameter is now the vertical component, and the second parameter is the horizontal component. But you can't do this. Java won't like this because this one conflicts with this one because it just looks like 2 integers. And Java can't tell, do you mean X then Y, or do you mean Y then X? Java has no way to tell now, is this X followed by Y, or is this Y followed by X? Java can't tell, so it won't allow you to have this one and this one. So these are overloaded constructor names, but overloaded constructor names can never have the same number of arguments. This one has 2 ints, this one has 2 ints, they conflict. This one has 1 int, this one has 1 int, so they conflict. So you can't do that. You have to, so I'm going to just comment this out. So I'll leave it in there so you can remember that the idea is that this one's not allowed because it's a conflict with the other one that takes 2 ints. And this one's not allowed because it conflicts with the other one that takes 1 int. But this, and this are allowed because this one takes no ints, this one takes 2 ints, this one takes 1 int. So Java has no problem matching these up. This one is the one that has no ints. These are the one with 2 ints. And this is the one with 1 int. Now, if I wanted to, I could use this one instead of this one. Be kind of weird. Almost everybody expects the horizontal component to come first and the vertical component to come second. If I really want to be weird about it, I could say, no, the vertical component comes first and the horizontal component comes second. I could comment out this constructor and keep this one, but that would be really bad programming style. You don't want to write your code in a way that dares people to understand it. You don't want to make things hard on people. So you try to write your code in a way that's the common way to do things. So when you talk about points, you always expect the first number in the point to be the horizontal component and the second number in the point to be the vertical component. Okay. All right. So now I've got constructors. Now there's other things I can do. Like if I mentioned, like I might use a point to represent the center of a circle. And in a graphics program, I might want to be able to drag circles around. Well, if you drag a circle around, you need to be able to move its center. So let's look at the idea of being able to move a point. So I'm going to give my point a method. I'm going to write public move, and I'm going to move horizontally by an amount delta x. So I'm going to define a method called move h that moves the point. When you call this method on a point, it moves the point horizontally by that much. Okay, and what I'll do is I'll say, well, this x should be updated to this x plus delta x. Okay, what about the y coordinate? Should I say anything about the y coordinate?
No.
No, if I don't do anything with it, it just stays the way it is. So this will move me right. Now, notice that I'm moving the point. I'm not returning anything. So this is a void method. It doesn't give back an answer. It just moves the point and doesn't say anything back. Now, let me, at the same time, do a couple more methods. If you can move horizontally, you might as well want to be able to move vertically, but I'll call that, just to make it easier to read, I'll call that delta y. I could just call it the delta. I move by that much, but I think it's better to call it delta y to help the person reading the code to say, oh, you mean you're going to change the y value. For all that matter, I could call this Bob and just say, okay, this dot y is this dot y plus Bob. Okay, that's going to compile, that's going to work, and someone's going to get real mad in the future when they have to read my code and they see a stupid variable name. Every once in a while, programmers will play a joke and put a really dumb variable name into a code somewhere, just as a joke, but usually you don't want to do that. You want a name that helps people understand. Now, delta would be okay. Remember, delta is used in science to mean change in something. In calculus, you talk about delta x when you're talking about defining the derivative, but it's not just a calculus term. It's ubiquitous in science to mean delta is something that's changing. It's the Greek letter delta became the English letter D, and the letter D is the first word in difference. So you're going to create a difference in something. That was what motivated delta to mean a change in, because you're going to create a difference in something. So delta for D, D for difference. And a different thing has been changed. So it's kind of a convoluted history, but okay. So now I could call this one delta. And up here I could say delta here too, because that's how much you're moving by. But on the other hand, if I say delta x here and delta y here, I'm making it even easier for people to read my code. I'm making it even easier for them. This one's changing the x coordinate, and this one's changing the y coordinate. Now somebody might say, well, you're calling move vertically, so you're not going to be changing the x coordinate. So they might say the y is redundant. And people actually argue about this stuff. You'd be surprised how picky people can be about naming things. And they'll say, well, the y is redundant because you're moving vertically, so of course you're deltaing the y variable. But I would say, no, it's better just to be a little bit redundant, make it a little bit clearer. Okay, so that's a nice variable name. Okay, and some people will abbreviate that to dy, like in calculus. Okay, you'll see people write dy here, like in calculus, dy dx. So if somebody doesn't like to type so much, you'll see this in a lot of people's code. dx's and dy's, change in x, change in y. That's not so bad. That's pretty accepted. Okay, but I'll leave it kind of verbose. Okay, all right. So now I can move horizontally, I can move vertically. Now, what if I want to move a point diagonally? I could move it in 2 steps. A diagonal move is a horizontal move followed by a vertical move. But on the other hand, I could just define another method. And that's what we do. We stock our objects up with lots of convenient methods. So I'll call this one just move, and I'll give it an int delta x and an int delta y. Okay, so now I've given people 3 different move methods to choose from. If they only want to move horizontally, they can just call delta h, and they don't have to call this one with a 0. See, if they want to move horizontally, they can call this one with a 0 for delta y, but they could also just say, I want to move horizontally, and use that name. It actually can make their code a little easier to read. You know, it becomes obvious when they call move h that they're moving horizontally. Okay. Whereas if they call move, they're making a move that's diagonal. You would use this for diagonal moves, and this for vertical moves, and this for horizontal moves. And it's thought that that makes your code a little bit, in the long run, that makes code a little bit more readable. People get to say what they mean. If they want to do a horizontal move, they call move h. And if they want to make a diagonal move, they call move. On the other hand, you could argue that these are redundant. You could get by with just this one. You could get by with just these 2. Okay? You couldn't get by with just this one, then you would never be able to move horizontally. So you could get by with just these 2, or you could get by with just this one, but it's actually nice to have all 3. Okay? And then let's use it up here. Let's p5 dot move horizontally by, say, 4. And then p5 dot move vertically by, say, 3. And then I can do p5 dot move -4, -3, which will put him back where he was. Okay, so that'll undo the 4, 3. Okay, now let's just visualize that. So we're going to be calling these methods now. And now we're updating what's in. Notice that we're only moving P5. So we're moving a specific object. Okay, let me step forward till I get to that code. Okay, now I've got my 5 objects. There's the one I want to move. There's P5. Okay, so I'm going to call move H. Move H is way down here, line 52. Okay, so I'm going to go to line. Well, see, I skipped to the first line of code. Notice that for a constructor, the opening brace was the first line of code, because for a constructor, the opening brace created the default object before you started filling it in. But for methods, the first line of there's nothing to do in the opening brace. For a method, the first line of code is the first line in the body of the method. So remember, for a constructor, the first line of code is this guy, which is thought of as that's where the blank object is built. Then you fill in the blank object. But for methods, there's nothing to do here. You just jump into the method. Okay. What is this method going to do? It's going to read 8. Then it's going to read this variable here. That gives it 8. That gives an 8 and a 4. Adds them together. That's a 12. And the 12 is put back in here. Okay. So read the instance variable. Read the parameter variable over here, instance variable over here, get those values, add them together, and put the result back here. See, there's the 12 in there. So 8 plus 4 is 12. Okay, now I'm ready to return. Okay, now when I return, the point has been changed. See how the point got changed? Remember, if I back up, see, the point was 8, 0 before I made the function call. Then after I make the function call, the point is 12, 0. I mutated, I updated, however you want to call it, I changed the point. This call moved that point. Yeah, the point moved from 8, 0 to 12, 0. Okay, now I'm going to do the same thing for this y coordinate. Now I'm going to use the same point. Now I'm going to move vertically, which means I'm going to move the y coordinate. So now I'm down here. I'm still pointing at the same. Notice that P5, that arrow is still there. See, this is the same object. See, this, see, inside this method, this is the object I was called on. See, I was called on the, I'm in this method, and the method was called on P5. When you're down here, the way the method knows who it was called on is this variable. Okay, this variable records this object you're working on. You're working on this notice we got a lot of these objects in memory, and we're working on only one of them at this point. This one. Okay, this one. Okay, so read the Y field in this object, read the Y, read the delta Y variable, local variable, get 3. So we got 0 and 3, add them together and put the result back in here. Okay, so we get 3 in there. So we've updated the object. Now we return, and now the object's been mutated again. So it went from 8.0 to 12.0 to 12.13. See, this object keeps changing. It changed. Now we're going to change it one more time. Now we're going to update both of the fields here. We've got 2 arguments, 2 parameters, and we're going to use them to update first the x coordinate, then the y coordinate. So we updated x and y. We've mutated. We call this mutating, or I mean, you can call it anything you want. Updating, changing. The fancy word is we're mutating. We're making this guy change himself. He's mutating himself. And see, now we get back here and the objects change back to. So remember, it was 8.0, then it was 12.0, then it was 12.3. Now it's back to 8.0. So this object changed. So the object got created, then got changed. Okay. Now, what else could we do? What else would a point want to do? Okay. Now, moving a point around. Okay. Now, here's an important thing. Suppose I'm using points to represent the center of a circle, and I've got 2 circles, and I want to know if their centers are the same. I want to be able to ask, is one point equal to another point? So if I had 2 circles and I was really using 2 points, 1 point for the center of one circle and 1 point for the center of the other, it'd be nice if a point could tell whether it's equal to another point. So here's what I'm going to write. I'm going to write a method, public, I'm going to call the method equals. That's the truth. When you want to check if 2 things are equal to each other, you always call the method equals. Now what this is going to do is I'm going to say that I'm going to check if this object is equal to some other point P. So when if I want to say if 2 things are equal, let me go up here and write the code up here. Here's what it's going to look like. I'm going to say this. Is P5 equals to P3? Okay. Now that's a Boolean, so I should get back an answer, and I'll store it in a variable B. Okay. I'm asking a question. Is P5 equals to P3? Now, that's actually the exact same thing as asking, is P3, doesn't really matter. I'll get the same answer. If you ask, is P5 equal to P3? Now, it's not the same thing. This calls the equals method on that object and passes that object as an argument, whereas this calls equals on this object and passes this one as an argument. So we'll see that they don't quite do the same thing, but they'll always give back the same answer. Okay. Another way to think about that is P3, or in algebra, if you say is A equal to B, that's the same thing as saying is B equal to A. You know, the asking for equality is symmetric. Asking if A is equal to B is the same thing as asking if B is equal to A. Now, I can't use, with objects, you cannot do this. I cannot say is P5 equal P3. That doesn't work in Java. This doesn't work. We saw that earlier when we talked about objects at the beginning. When we played around with objects, like even with strings, you can't really ask that question. You're not supposed to ask, is an object equal to another object this way? You're supposed to do it with this method. You're supposed to use a method. So you call this method on one of the two objects and pass the other object as a parameter. Okay? So, but it doesn't matter what order you do it in. You get the same answer either way. Okay? Now, over here, this thing should be returned Boolean. So this method is going to take a point, and here's what it's going to do. It's going to return a Boolean value. Now, what it wants to do is it wants to look at this x and compare it to P's x. And it wants to take this y and compare it to P's y. And if those are both equal, that's what we mean by 2 points are equal if their x coordinates are equal and their y coordinates are equal. So the x coordinate from this guy, the x coordinate from this guy is equal to the x coordinate from the other guy, and the y coordinate from this guy is equal to the y coordinate from the other guy. In fact, the other guy, in a lot of people's code, they write this. So you end up with this. This x and that x. This y and that y. I've seen plenty of people who like to write it this way. I'm saying I've got this point and I've got that point. Those are my 2 points, and I want to know if they're equal. This point and that point are equal if this x is equal to that x and this y is equal to that y. Now, this is a word in Java. That is just, people think, is a clever way to write this. So this is an important word in Java. That is just a word people think is clever. This and that. In fact, here it's hard to say whether it's better to say P for point or that. Okay, I'll leave it for now for that. Java people rarely actually use this, but JavaScript people use it all the time. When you learn more about programming, as you learn more language, you see that there's different cultures among different programming languages, and the JavaScript people like to use this and that. Java people rarely use that. Java people would probably call this one P for point, or even spell out point. Spell it out. It's the parameter is called point. I would prefer just, in this case, P for point. Okay. So Java people would probably use P or point. JavaScript people, they like that, this and that. Okay. But now let's actually watch this run. Oh, what did I forget? Oh, I forgot to put the semicolon at the end of that. Okay. Okay. Let me step through I got a lot of code to step through now. Okay. Here I am, line 17. I'm about to ask, is P5 equal to P3? Now, P5 is this, P3 is that. Clearly they're not equal, but I'm going to find that out. Okay, clearly they're not equal, but what I want to do is watch how it looks. Okay, so I'm going to jump down to this. Now remember, P5 is going to be this. So in our method, the keyword this will point to P5, what is normally called P5. And the parameter that will point to P3. So we'll have that pointing to P3 over, where's P3? P3 is here, okay? So go forward one step. Oh, actually, I had already done, let's see. Okay. Here, now we're at line 17. See, now, actually, a minute ago, we were at the end of line 17. Now we're at the beginning of line 17. Okay, so now we're here in line 17. So now we're going to jump into the equals method. Here's this and that. This is P5, and that is P3. See, that is P3. Notice if you hover over these arrows real carefully, they've turned red, which is convenient. So sometimes to sort them out. So this object here is that, and this object here is also P3 in main. Okay, so P3 became that, but we called the method on P5, so P5 is this. Okay, and now this X would be 8, and that X is 4, and they're not equal. So this is false. So you don't even need to check this, because false, and it doesn't matter what's over here, false and anything is false. So the Java is actually going to quit right there. It doesn't even bother to check the right-hand side because it sees that this X is not equal to that X. Okay, so this is going to return false. So it's realized that this guy's false, so it's going to return false. We're going to return to line 17. Go way back up here, line 17. Right now we're doing the right-hand side of line 17. We need to return to line 17, create B, and put the value false in it. Okay, so when I click forward, we're going to go back to line 17. See, we're at line 17, and we're about to do the left-hand side of 17. We're about to create B holding false. Okay, and now line 18 is going to do the same thing, except line 18 is going to reverse to this and that. P3 is this, and P5 is that. Okay, this is now P3, and that is now P5. Okay, but we end up getting the same answer. Okay, but it's, you know, notice it's not the same thing, it just gives the same answer. Changing the order of calling equals always gives you the same answer, but it's not quite the same thing, because this is calling a method on this guy, this is calling a method on that guy. This is using this as a parameter, this one's using that as this one's a parameter. So they always give the same answer, but they don't do the exact same thing. Okay, now down here, yeah, it just does the calculation. Now it's ready to return false again. So now we're going to return false back to line 18. There we are in line 18, and we're about to put another false in B. Okay, so we just put another false in B. Okay, all right, so now we've got, notice we've got a bunch of different kinds of things here. We've got constructors. We've got methods that mutate the object and don't return anything. And we got methods that ask questions about the object and return a value like Boolean. Okay, now here's another thing that we might want to ask a point. You might want to ask a point, where are you? What is your X coordinate? Where are you? So I might want to do something like int X equal P3.x. I might want to ask the object where it is, get its X coordinate. And I can do int Y equals P3.y. Okay, all right. So now this will work. Let's see, go to the, okay, so here I'm at line 20. I'm at line 20, and I'm about to create a variable X that holds, what this does is it says, reach into P3, get a copy of its X value. So reach into P3 and get a copy of its X value and store it in a local variable X. Okay, that X is not that X, which is not that X, which is not that X, which is not that X. See how many X's? That's why we call this a local X. These are instance variables. That X belongs to that instance. That X belongs to that instance. So that's where they get the name instance variables. This is a variable in an instance of the point class. Okay, so I reached into an object and got out a copy of its value. And now I can reach in and get a copy of its Y value. Okay, now it turns out that in object-oriented, in a lot of Java code, you don't want people reaching inside of your objects. So you can make this thing private. Now my code does not compile because X has private access and point. You're not allowed to poke inside of the object. This is a pretty common strategy in object-oriented programming. You don't have to do it this way, but 9 times out of 10, people do it this way. They make the data in an object what's called private. So no one can poke in there and see the data. But then if I can't poke in there and see the data, how can I get the data? So what we do is we define methods that let you look at the data. So what we'll do is we'll define a method called Now, we don't have to define. If we truly want the data private, we don't even let people do this getting of the data. Okay, so sometimes you want your data so private, you don't even provide a method to let someone look inside of your object. It's very common for objects to be what's called opaque. You cannot see inside of them. Okay, so you make the fields private, then that prevents people from just reaching inside the object. Then if you want, you can either provide a method that lets people see what's inside the object, or you can just not even provide these methods and make the methods opaque. Okay, and then I could do various things here. Like I could let some people see inside, like I can make this method clever and let some people see inside the object and not let others see inside the object. But for now, we'll just let anybody see inside of it, and it's just going to return this dot x. Okay, so now up here, instead of saying int x is p3 dot x, I'll say p3 dot get x. Okay, and this will be p3 dot get y. I'll define a get y method. So I'm letting someone ask me for the data in the object. So instead of letting somebody reach inside of the object, I'm saying, well, ask nicely and I'll give you what's inside the object. Okay, so I can write a get x and I can write a get y. And not much difference here. Now, this is real common in this kind of code. Lots of redundant code. Notice there's lots of very short, somewhat similar looking methods. Okay. Now let's look at the homework assignment. We've got a couple minutes left. Let's look at the homework assignment. The homework assignment is for you to do a lot we're doing here. There's a point method in the homework assignment that's already been written. Okay, so it's a version of what we've been doing today. Let me open the Java visualizer. I'm sorry, open the Dr. Java. Okay, so there's a point class, that's got a lot of what we just did today filled in for you. Okay, then it's got a circle class that you have to do work on. A circle is a center and a radius. See, it's a point that represents the center and a double that represents the radius. And you have to put a bunch of methods in here. Now, the HTML file tells you what to put into it. So here's a description of what you're supposed to put in the besides the circle class, there's a rectangle class. Now, a rectangle class is a corner, which could have been a point, but I chose not to make it a point. That's the upper left-hand corner of the rectangle, and then a width and a height. That's similar to the picture we drew the other day in class. That's how Java thinks of rectangles. That's how most programmers think of rectangles. If you go back here, we drew a picture the other day. Oh, did I forget to put the picture up there? Oh, I forgot to put the picture up there. We drew a picture of a rectangle. I'm sorry. I should have put I'll put the picture up there. There's a copy of the picture from the other class. Okay. I forgot to put, we drew this picture in class, but I forgot to put it up there. See, there's the upper left-hand corner. That's the X and Y. And then there's an integer that describes how tall the box is, rectangle is, and how wide it is. Okay. So a rectangle is defined by 4 ints. Now these two could have been a point, but I chose to make them just 2 ints. Okay. All right. And then I gave you one constructor here. For the circle class, I didn't even write, you have to write the constructors. Then in this description here, it tells you in the rectangle class, write those methods. It tells you what they do. Then there's a file that tests your methods. So in the homework assignment, there's a file that this will compile. Oops. After you finish step 1 of writing some stuff in rectangle, this will compile, and then when you run it, you should get an answer that looks like this. If you get that output, you did the right thing. Okay, so step 1 of the homework assignment. So step 1 is to put these methods into rectangle, then run this test file and make sure you get the right output. Then step 2 is to put these methods, these constructors, into circle and these methods into circle, and then run a test. Then step 3 is to put a couple more methods in the rectangle. And then step 4 is to put a couple more methods in the circle. And they get a little trickier as you go along. These are real simple. They're very similar to the ones we just did in the point class. So you notice move, grow, things that change. Move changes the X and Y coordinates. Move. This is move to that point. This is move by a delta. This is grow to that dimension, grow by those deltas. Okay, so these are real similar to the point, what we wrote for point. And you also have the point class in the homework, so you can read the point class to get reminded about how to write these things. Okay, so the first bunch are pretty easy. Then there's a similar group in circle that are pretty easy. There's a bunch of move and grow. Then this is where it gets a little bit tricky. Then you go back to the rectangle, and it asks you to tell, does the rectangle contain a point? Okay, so if you have a rectangle and you have a point, you can ask, is the point inside the rectangle? So that's this method. It asks, it's a Boolean. Now the point can be described as an XY, or the point can be described as a point object. They kind of mean the same thing. So these methods are kind of redundant, and there's a hint here that if you've written one of them, you can use one of them to write the other one. You don't actually have to write both of them. If you've written this one, there's a real easy trick to use this one to write that one. On the other hand, if you write this one first, there's a real easy trick to use that one to write this one, because it doesn't really matter if a point's represented this way or that way. Okay, and then there's the last thing is, if I give you 2 circles, you can tell me if they overlap or not. 2 circles overlap if their centers are close together. If the distance between their centers is less than the sum of the radiuses, they overlap. And if you go over here to the point class, it knows how to compute the distance between 2 points. So you'll use that. The points know how to compute the distance between themselves. So you can use that to compute this overlap function. If the distance between the 2 centers is less than the sum of the radii, the circles overlap. And then you can also ask, is this circle got its center inside of that rectangle? Well, that's just this contains method. You're asking, is the center of the circle contained in the rectangle? Okay, so you can write this method in terms of this method, and that's explained here. Okay, so that's what your homework assignment is. You're going to write a lot of little 1- and 2-line methods, just like this. You're going to be writing lots of 1- and 2-line methods. Well, every one of these is a 1 or a 2-line method. Every one of these is just 1 or 2 lines of code. Okay, So that's the homework assignment. It's practice in writing these simple little methods like you see in objects. Okay. Again, you fill in this, and every time you finish the step, you can test it. You can run the test program and you should get that output. Okay. Then when you've done another step, you'll run this step program and you should get that output. And that output will show up in Dr. Java's output window, and you just compare it. You'll need to compare that output with what the program puts into the Dr. Java output window. So you'll have to compare them carefully. After you update this, and you'll open the test program. You don't make any changes here. You just now they won't compile right now because you have to make changes to rectangle before this thing will compile. But when you make the correct changes to rectangle, then the test one will compile and it'll run, and its output should look like that. Okay. All right. So we should quit there. You're not going to write a whole lot of code, and this is really good practice for learning, for reviewing what we've been talking about today. Writing this kind of code, it's not hard. It's you're writing about 10 or 15 1- and 2-line methods. You just have to understand the idea of what we're doing. So it's not at all hard. It doesn't take a very long time, but you do have to sort out the ideas. Okay. So this is a very good assignment for understanding, for you to do what we did in class today of, let's see, where was it? Of writing this kind of stuff here. Yeah. You get to practice writing these little 1- and 2-line methods. Okay? All right. So if you have questions about the homework, send me an email. Look, download it, look it over, and if you have any questions about it, send me an email. Okay? And have a nice weekend. We'll meet again on Tuesday, and start the homework assignment and send me emails if you have questions. Okay? Bye-bye.